What if everything we were taught about the origins of human civilization, every textbook, every timeline, every carefully constructed assumption we've built our entire understanding of history upon, was built on a foundation that contains a 12,000-year blind spot? And look, I know how that sounds. Trust me, I know. When I first came across this research, I almost didn't make this video. I sat with it for weeks, trying to find the obvious hole, the pseudoscience footnote, the moment where it all collapses into wishful thinking. And I found some of that. But I also found something I wasn't expecting, a genuine, unresolved, scientifically legitimate question sitting at the very center of human history. And once I found it, I couldn't put it back. In this documentary, we dive into the one chapter of Earth's history that mainstream science has spent decades trying to close, and why it refuses to stay shut. We're going to look at geological evidence that's been sitting in soil samples for decades. We're going to look at the mechanics of how an entire civilization could be erased without leaving a single artifact. We're going to look at DNA data from Harvard's most advanced genomics lab that shows population collapses in a window that aligns, uncomfortably, with a specific catastrophic moment in Earth's past. And we're going to look at what mainstream archaeology is, slowly, reluctantly, beginning to acknowledge. 3 things I want you to walk away with today. First, the geological evidence that was ignored for decades and what it actually shows. Second, the scientific reason why the absence of evidence here is not the same as evidence of absence. And third, the thing that even cautious, mainstream scientists are now beginning to say out loud. Let's go. Roughly 12,800 years ago, something happened to Earth that we are only now beginning to fully understand. The period is called the Younger Dryas. It runs from approximately 12,800 to 11,600 years before the present. And what happened in that window is this: the average temperature of Earth dropped between 10 and 15 degrees Celsius. Not over thousands of years. Not over centuries. Over a few decades. If you need a comparison for scale, that is the fastest and most severe climate shift in 2.6 million years of measurable Earth history. The last time the planet changed this quickly, our entire genus was still figuring out stone tools. The first evidence we have for this comes from ice cores. Specifically, the GSP-2 core drilled from the Greenland ice sheet, one of the most detailed climate archives on the planet. When researchers analyzed the oxygen isotope ratios in that ice, they found a temperature boundary so sharp, so sudden, that the initial scientific response was to assume the measurement equipment was malfunctioning. It wasn't. The boundary was real. The change was nearly instantaneous in geological time. Then there's what archaeologists started calling the black mat. Across more than 50 archaeological sites on 4 continents, sites that have nothing else in common, separated by thousands of miles, there is a thin, dark layer of sediment sitting at precisely the same point in the stratigraphic record. The same timestamp, everywhere. Above that layer, no woolly mammoths. Below that layer, abundant woolly mammoth remains. Whatever the black mat marks, it marks a line that something, many somethings, did not cross. In 2007, a research team led by Richard Firestone at Lawrence Berkeley National Laboratory published a paper that sent shockwaves through the geological community. They had found something inside that black mat layer, nanodiamonds and platinum group element anomalies. Nanodiamonds are not formed by ordinary geological processes. They form under extreme pressure, the kind of pressure generated by a cosmic impact event. The platinum anomaly independently corroborates an extraterrestrial source. Together, they point toward what researchers now call the Younger Dryas impact hypothesis, the proposition that Earth, at 12,800 years ago, was struck by a fragmented comet or asteroid, triggering a cascade of consequences that included a near-instantaneous climate shift, catastrophic wildfires, and a global ecological collapse. The biomass-burning evidence is staggering. Sediment cores from that boundary layer show a global spike in charcoal, soot, and polycyclic aromatic hydrocarbons, the chemical signature of fire on an enormous scale. Some estimates suggest that approximately 10% of Earth's total biomass burned in an extremely compressed time frame. That's not a regional disaster. That is a planetary event. You know what's strange about all of this, though? The black mat, that thin, dark line sitting in the soil under archaeological sites across the world, was there for decades before anyone thought to ask what it was. Archaeologists walked past it, dug through it, cataloged it as sterile layer, or just noted it in passing. It wasn't mysterious to them. It was just the dirt. And that detail haunts me a little, because it tells us something about the limits of looking only for what you expect to find. I want to be clear, the Younger Dryas impact hypothesis is still a hypothesis. It's contested. There are serious scientists who argue the evidence can be explained by other mechanisms. But the number of peer-reviewed papers supporting it has grown from 1 in 2007 to more than 50 in 2024, with verified sites on every inhabited continent. This is not a fringe idea anymore. It is a live scientific debate, and that distinction matters enormously for everything that follows. So we have the reset button. We have the date. We have the scale. Now the question that changes everything: who, if anyone, was alive when it was pressed? Because here's what nobody talks about: the Younger Dryas didn't start from nothing. It started from a world that had already been inhabited for at least 200,000 years. Homo sapiens, anatomically modern humans, humans with the same skeleton you're carrying right now, appeared on this planet approximately 300,000 years ago. That date was revised upward significantly in 2017, when remains from Jebel Irhoud in Morocco were dated to around 315,000 years ago, pushing our species' origin back by nearly 100,000 years from previous estimates. Behavioral modernity, symbolic thinking, abstract representation, forward planning, appears in the archaeological record at least 100,000 years ago, and some evidence pushes it further. So here's the question that has been bothering me for 6 months of research: if Homo sapiens has existed for 300,000 years, and we define civilization as starting roughly 5,000 to 6,000 years ago with Mesopotamia and the Nile Valley cultures, what exactly were we doing for the other 294,000 years? The conventional answer is surviving. Hunter-gatherer subsistence. Living day to day, season to season, without surplus, without specialization, without the conditions that generate complex society. That's the standard model. And I want to be honest, it's not a stupid answer. There are good reasons to think it's substantially correct. But here's where it gets complicated. The Blombos Cave site in South Africa has given us ochre processing workshops, engraved geometric patterns on ochre pieces, and perforated shell beads, all dated to between 75,000 and 100,000 years ago. None of that is survival behavior. You don't engrave geometric patterns on a piece of ochre because you're hungry. That is abstract thinking, aesthetic impulse, symbolic communication. It is the internal architecture of complex culture expressed in the only medium available at the time. And then there's this: the brain of a Homo sapiens who lived 40,000 years ago is, in every measurable respect, identical to the brain you're using right now to process this information. Same structure. Same capacity. Same neurological hardware. If you took a child born 40,000 years ago and raised them in the modern world, they could learn calculus, write poetry, debug software, argue philosophy. The cognitive gap between us and them is zero. There is no cognitive reason why complex civilization couldn't have appeared much earlier. The timeline asymmetry here is genuinely difficult to explain away. We went from stone tools to smartphones in approximately 10,000 years. That 10,000-year run, starting roughly at the end of the Younger Dryas, produced everything we recognize as civilization. Before that, 290,000 years. Same brain. Roughly the same population density in some regions. And apparently, nothing comparable. Either the preconditions simply never aligned, or something comparable existed, and we're not finding it. Those are the two options on the table. I keep coming back to this thought, and bear with me here, every single person alive 13,000 years ago had the same brain you're using right now to watch this video. The same capacity for wonder, for grief, for obsession. The idea that none of them ever looked at the stars and decided to track them systematically, or organize themselves into something more structured than a roving band, it doesn't sit right with me. And apparently I'm not the only one who feels that way. The population numbers matter here too. At peak pre-Younger Dryas estimates, somewhere between 5 and 10 million people were living on Earth. That's not a trivial number. 5 million people, distributed across a planet, with 200,000 years of cultural accumulation and the cognitive capacity of modern humans, that's enough substrate for complex social organization. The question is whether any of it survived. So what would it actually take, physically, practically, for an advanced civilization to exist and then disappear completely? Let's look at the mechanics of erasure. Because it turns out, making a civilization vanish is not as hard as it sounds. In fact, Earth does it automatically. And it's been doing it the entire time. This is the part of the documentary that I think matters most, more than the dramatic sights, more than the anomalous artifacts. Because this section is what determines whether the absence of evidence means anything at all. And the answer is more sobering than almost anyone outside specialist geology fully appreciates. If a civilization existed in the period between 12,000 and 15,000 years ago, here is what happens to its physical record over the next 12,000 years. Factor 1. Sea level rise. The end of the Ice Age was not just a temperature change. It was the melting of ice sheets that had locked up an enormous fraction of the planet's fresh water. As those sheets collapsed, sea levels rose by approximately 120 to 130 meters compared to their lowest glacial point. That is a vertical rise equivalent to a 40-story building, distributed across every coastline on Earth. The land area lost to this flooding was staggering, roughly equivalent to the combined area of Asia. And here is the critical point: throughout all of recorded human history, approximately 80% of major civilizations have developed on coastlines and river mouths, exactly the low-lying zones that would have been swallowed first and most completely. If you wanted to design a mechanism for erasing civilization from the record, you could not do better than a 130-meter sea level rise directly targeting the places where people built things. Factor 2. The biological clock of organic material. Wood, textile, leather, rope, paper, anything derived from once living organisms, in normal soil conditions, virtually none of it survives beyond 10,000 years. A wooden structure from 13,000 years ago doesn't just decay, it dematerializes. The same is true of everything made from fiber, hide, or plant material. If their built environment relied on these materials, as essentially every pre-metal cultures did, there is nothing left. Factor 3. Oxidation. Most metals corrode. Iron rusts to dust in a few thousand years of soil exposure. Copper and bronze oxidize and leach into surrounding sediment. Even gold-copper alloys suffer significant surface degradation over geological timescales. Unless a hypothetical civilization was producing stainless steel-grade alloys, which we have no reason to expect, their metalwork is gone. Factor 4. The glaciers themselves. Ice sheets kilometers thick moved across most of North America, Northern Europe, and Northern Asia during the last glacial maximum. They didn't just sit there, they moved, grinding bedrock, transporting material hundreds of kilometers, and depositing it in completely different locations. Any structure or surface feature beneath those ice sheets was destroyed or relocated. The ground-level record of anything that existed in those regions before the ice advance has been mechanically erased. Factor 5. The impact event itself. If the Younger Dryas impact hypothesis is correct, add to all of the above, a global firestorm, megatsunamis generated by either impact directly or destabilized coastal sediments, acid rain from atmospheric loading of sulfur compounds, and a multi-year impact winter from dust and soot. This is not incremental erosion. This is active sterilization. Here's a thought experiment I find deeply unsettling. If every city on Earth were abandoned today, right now, how much would remain recognizable in 12,000 years? Reinforced concrete has a functional lifespan measured in hundreds of years before cracking and spalling. Structural steel in exposed conditions rusts through in decades. Glass shatters. Asphalt dissolves under biological and chemical attack. The Amazon rainforest would reclaim Sao Paulo within about 400 years of abandonment. The jungle would be indistinguishable from primary growth. Give that process 12,000 years, and you'd have some unusual mineral concentrations in certain soil profiles. Possibly some anomalous topography. A geologist might raise an eyebrow. An archaeologist walking through would see jungle. Stonehenge is roughly 5,000 years old. Look at it, it's visibly weathered, some stones have fallen, the precision of the original arrangement has degraded. Double that age to 10,000 years, and even standing stones begin to lose their engineered profile to weathering. Double it again to 20,000 years, and the stones are still there, but the structure, the spatial relationship, the intentionality, has likely been obscured beyond recognition without careful excavation. So we've established the delete mechanism works. The question now is, are there files that survived? Anomalies that the erasure machine missed? Evidence that has been sitting in plain sight for decades, and the story of why it was ignored is almost as fascinating as the evidence itself. Let's talk about the sites. The concrete, physical, datable locations where the conventional timeline runs into things it can't easily explain. Göbekli Tepe, in southeastern Turkey, was excavated beginning in 1994 by the late Klaus Schmidt of the German Archaeological Institute. What he found has never been fully reconciled with the standard model of prehistory. The site consists of massive T-shaped limestone pillars, arranged in circles, covered with elaborately carved reliefs of animals, foxes, vultures, scorpions, boars, cranes, executed with unmistakable artistic sophistication. The individual pillars weigh up to 20 tons. The oldest layers have been dated to approximately 11,600 years ago, right at the moment the Younger Dryas ended. Here is the problem: according to the mainstream archaeological model of 1994, there should have been no one capable of building this. The site predates agriculture in the region. It predates settled communities. It predates pottery. The standard model held that complex monumental architecture required a sedentary agricultural society to generate the surplus labor and organizational capacity necessary for construction. Göbekli Tepe arrived as a standing refutation of that sequence. Klaus Schmidt himself said it plainly: first came the temple, then came the city. The implication being that Göbekli Tepe was not the beginning of something, it may have been the inheritor of a tradition considerably older than anything we've found. The site was also, notably, deliberately buried, filled and intentionally sometime around 8,000 years ago. By whom, and why, remains unknown. Moving to the other side of the planet, Gunung Padang in West Java, Indonesia. This is the site that triggered the most intense scientific controversy of the last decade in this field. A 2023 paper published in the peer-reviewed journal Archaeological Prospection reported the results of ground-penetrating radar, seismic tomography, and core drilling at the site. The authors, including geologist Danny Nadawajaja, argued that the deepest structural layers of the mound showed evidence of human construction dating potentially to between 25,000 and 27,000 years ago. If accurate, that predates the last glacial maximum. It predates the conventional, behavioral revolution. It is extraordinary. The response from mainstream archaeology was fierce: criticisms of methodology, questions about interpretation of the geophysical data, calls for more independent verification. The paper was not retracted. It remains in the literature, contested and unresolved. Off the southern coast of Japan, near the island of Yonaguni, a series of underwater structures were discovered by a diving instructor in 1986. The Yonaguni Monument, as it became known, consists of stone formations at depths of 5 to 27 meters, featuring flat surfaces, right-angle cuts, step-like terracing, and what appear to be carved channels and pillars. At the peak of the last ice age, with sea levels 120 meters lower, the area where these structures sit was dry land. The debate about whether the formations are natural or partially constructed continues, but the geological context is not disputed. If anything there was built, it was built when that rock was above sea level, at minimum 10,000 years ago. Then there's the Sphinx. And here I want to be precise about what the argument actually is, because it's often misrepresented. Boston University geologist Robert Schoch, a credentialed academic geologist, not a fringe figure, examined the erosion patterns on the body of the Great Sphinx at Giza in the early 1990s. His conclusion, based on the morphology of the weathering, was that the erosion on the Sphinx's body was caused primarily by water runoff, specifically by heavy, prolonged rainfall, rather than by the wind and sand erosion that dominates the Giza Plateau in the historical period. The last time Egypt received the kind of sustained rainfall that would produce that weathering profile was between roughly 7,000 and 10,000 BCE. Schoch's argument is that the erosion pattern implies the Sphinx body was carved, or at minimum substantially shaped, during that wetter period. The Egyptological community rejected this vigorously, primarily on the grounds that there is no other archaeological evidence for an Egyptian civilization capable of building the Sphinx in that period. Which is, of course, exactly the circular problem at the heart of this entire conversation. What's worth noticing is not any single one of these sites in isolation. It's the pattern. Every one of these anomalies clusters around the same window, 10,000 to 12,000 years ago. Every one has been met with some degree of institutional resistance. And every one involves evidence that is not fabricated or imaginary, it is real physical data being interpreted in ways that the mainstream model finds uncomfortable. The question is whether uncomfortable and wrong are the same thing. I want to be clear about something. I'm not saying any of these sites prove a lost civilization existed. I'm saying something more uncomfortable than that. The way some of these findings have been received tells us as much about how science responds to paradigm challenges as it does about the past. And that is worth sitting with for a moment, before we move to the people who have the strongest case against everything I've just said. Let's steelman the critics. Because they have real points, and their arguments are not dismissible, and understanding them makes the mystery sharper, not duller. The most important objection is this: the absence of evidence problem is genuine. If a civilization existed that was sophisticated enough to construct Göbekli Tepe-level monuments, to encode astronomical knowledge in architectural alignments, to maintain long-distance trade networks, that civilization would also have produced middens, garbage dumps, burial sites, modified landscapes, pottery fragments. These things survive. We find them from 40,000 years ago, the Venus figurines, the cave paintings of Lascaux and Altamira, the carved lion man of Hohensteinstadel. These artifacts are fragile, organic adjacent, and they survived. Pottery sherds from ordinary cooking fires from 30,000 years ago turn up in Chinese and Japanese sites. If a civilization with organizational complexity existed, it should have left at least some of this debris, and we haven't found it in the relevant window, at the relevant scale. That's a real argument. It cannot be waved away by pointing at sea level rise alone. The second objection concerns what we might call the Atlantis exhaustion factor. Since Plato wrote his dialogues roughly around 360 BCE, every century has produced a wave of lost advanced civilization enthusiasm. Each wave has drawn genuine intellectual energy, attracted serious thinkers, and ultimately failed to deliver. Pseudo-archaeology, the non-rigorous, confirmation-bias-driven version of this inquiry, has caused measurable harm to legitimate archaeological sites, misappropriated indigenous cultural heritage, and diverted funding and attention from serious research. The fatigue is justified. The skepticism is warranted. It has been earned. Third, Graham Hancock, who is the most prominent public voice arguing for a pre-Ice Age civilization, has been credibly accused by mainstream archaeologists of a specific methodological failure, starting with a conclusion and selectively assembling evidence to support it, rather than following evidence to a conclusion. That's not a minor procedural quibble. That is a violation of the scientific method. His critics are right to raise it, even when they're wrong about individual pieces of evidence he cites. Fourth, and most philosophically important, Occam's razor. Hunter-gatherers building Göbekli Tepe is surprising. It challenges our assumptions about what non-agricultural societies could achieve. But it does not logically require us to postulate a lost civilization. Cognitive capacity plus religious motivation plus decades of coordinated effort can build Göbekli Tepe. We don't need a prior civilization to explain it. The simplest explanation that fits the evidence is the one science correctly defaults to. What the skeptics get right: extraordinary claims require extraordinary evidence, and that evidence hasn't arrived yet. No smoking gun. No unambiguous pre-Ice Age city. No artifact that definitively places complex society before the accepted timeline. Honestly, when I first started researching this video, I was ready to debunk the whole thing. I expected to find fringe theories propped up by motivated reasoning. What I found instead was a legitimate methodological dispute sitting inside a field that doesn't have clean tools for resolving it. That's not as satisfying as a clear answer. But it's the truth of where the research actually is. So we have a genuine standoff. Anomalies that don't fit. Explanations that don't fully satisfy. A geological record that may have erased the very evidence we need. But in the last decade, a new tool has entered the conversation. And it's changing what's possible. LiDAR, light detection and ranging, works by firing rapid laser pulses from aircraft toward the ground and measuring the return time with extraordinary precision. The result is a three-dimensional topographic map that can, critically, filter out vegetation. The jungle canopy disappears in the data. What you see is the bare ground surface, and whatever is on it. In 2018, a LiDAR survey was conducted over approximately 2,100 square kilometers of jungle in northern Guatemala. The results, published in the journal Science, revealed 60,000 previously unknown Maya structures. Not 60. Not 600. 60,000. Pyramids, causeways, reservoirs, agricultural terracing, defensive earthworks, an entire urban and agricultural landscape that 150 years of ground-based archaeology had completely missed, because it was invisible under the forest canopy. The survey took days to conduct. It rendered obsolete a century and a half of accumulated assumption about the scale of Maya civilization. A 2015 LiDAR survey of the Angkor Wat region in Cambodia revealed that Angkor was not the bounded temple complex previously understood. It was the center of the largest pre-industrial city in human history, with urban infrastructure spreading across an area that dwarfed the previous estimates by a factor of 2. Again, invisible from the ground. Revealed in days by the right instrument. The lesson both of these discoveries teach is blunt and important: absence of evidence was not evidence of absence. It was absence of the right tool. Now here is where this becomes directly relevant to what we're discussing. The problem with applying LiDAR to pre-Ice Age coastal settlements is that 90% of the most relevant sites are currently underwater. LiDAR penetrates vegetation, not ocean. But submarine sonar mapping technology is improving at a significant rate, and what it's beginning to show is remarkable. The North Sea floor, the body of water between Britain and mainland Europe, was, during the last glacial maximum, a land area roughly the size of Britain and Ireland combined. Researchers call it Doggerland. It had rivers, hills, wetlands, and by every reasonable demographic inference, a substantial human population. It was flooded completely as the ice melted, likely in a catastrophic single event around 6,200 BCE when a massive submarine landslide off Norway, the Storegga Slide, generated a tsunami that may have finally submerged the last Doggerland highlands. News sonar mapping published in 2023 is beginning to reveal complex topography beneath the North Sea floor, ancient river channels, lake beds, elevated areas that were once hills, hinting at habitation sites that have never been excavated because no one knew where to look. Similar mapping programs are underway on the Sunda Shelf in Southeast Asia, the undersea plateau that, at glacial maximum, was a landmass larger than all of modern India, connecting present-day Vietnam, Malaysia, Borneo, Sumatra, and Java into a single landmass. Population genetic studies suggest this region was one of the most densely inhabited areas of the ancient world. Almost none of it has been surveyed archaeologically, because most of it is under 50 to 100 meters of water. There's something almost poetic about this. We went from, "there's nothing there," to, "there are 60,000 structures there," in a single flight over the jungle. I don't think that should make us feel foolish about what we missed. I think it should make us feel genuinely humble about the 98% of Earth's land surface that hasn't been systematically surveyed, and the additional 25% of former land surface sitting under shallow coastal water. Technology is opening doors we didn't know existed. But while we wait for the underwater surveys, there's another line of evidence that doesn't require excavation. It's already inside every one of us. And what it says about our deep past is extraordinary. Human DNA. Ancient DNA analysis. This is the section where I think the evidence gets hardest to dismiss, because it comes from a completely independent methodological tradition: no shovels, no ruins, no site interpretation disputes. Just mathematics and molecular biology. David Reich at Harvard University runs what is widely considered the world's leading ancient genomics laboratory. His team's work over the last decade has revolutionized our understanding of human prehistory, repeatedly overturning prior consensus models with genetic data that couldn't have been fabricated or misinterpreted in the same ways physical archaeological evidence can be. A 2022 study from his group confirmed a population bottleneck event approximately 900,000 years ago, a near-extinction event for our ancestral lineage that was previously unknown. But more relevant to our timeline, Reich's lab and others have documented regional population collapses in the range of 10,000 to 15,000 years ago across multiple continental populations, independently of one another. These are not connected communities collapsing for the same social reasons. These are separate populations, on separate continents, showing genetic signatures of catastrophic reduction within the same broad time window. The mitochondrial DNA analysis of modern humans globally shows haplogroup distribution patterns consistent with several regional population wipeouts followed by repopulation from surviving groups. Some of these temporal markers align with the Younger Dryas boundary. Then there's the Solutrean population. The people who created the Solutrean culture in Western Europe, spanning roughly 22,000 to 17,000 years ago, produced the most technically sophisticated stone tool assemblage of their era. Pressure-flaked bifacial points of extraordinary thinness and regularity, requiring skill that takes years to develop. These people were not simple. And then, around the time the Younger Dryas begins, their genetic lineage essentially vanishes from the European record. Not gradual replacement, interruption. Their descendants are virtually untraceable in modern European DNA. The lineage was cut. But the finding I keep returning to, the one that I genuinely cannot make myself comfortable with, is what geneticists call ghost populations. David Reich's research has identified ancestral populations that contributed significantly to the modern human genome but have left no known archaeological trace. One such ghost population contributed between 30 and 40% of the ancestry of indigenous populations across the Americas and parts of East Asia. 30 to 40%. That's not a trivial genetic contribution. That is a substantial ancestral lineage. And we have no idea who they were. We don't know what they called themselves. We don't know what language they spoke. We don't know whether they lived in structures or under open sky. We don't know what they made or built or believed. They are present in the mathematics of our genome and absent from every other form of record. They lived, survived long enough to have descendants who survived, passed their genes into populations that persist today, and then disappeared into complete archaeological silence. There is also the question of oral memory. Researchers have now cataloged over 200 distinct cultural traditions from every inhabited continent that contain narratives about a great flood or catastrophic inundation event, typically described as occurring in a remote but not infinitely distant past, often with survivors who preserve knowledge or culture into a new era. 200 cultures, independently. Many of these traditions have been maintained for thousands of years with remarkable consistency. The degree to which convergent oral testimony constitutes data is genuinely debated in academic circles now. It is not dismissed as it once was. Emerging work in epigenetics adds another layer that I want to be careful about. This research is preliminary and genuinely contested, and I don't want to overstate it. But researchers have documented heritable epigenetic markers resulting from extreme stress events, famine, catastrophe, societal collapse, that persist for multiple generations in descendant populations. Some researchers are cautiously examining unusual epigenetic patterns in populations descended from regions most heavily affected by Younger Dryas disruption. I'm not citing this as established evidence. I'm citing it as an area of active inquiry that would have been laughed out of a conference room 20 years ago. Let me put this synthesis together plainly. We have a geological reset event dated precisely to 12,800 years ago. We have a sea level rise that drowned the world's coastlines, the specific places where civilization would have been concentrated. We have genetic population collapses in the right time window, from independent populations on separate continents. We have oral traditions from 200 cultures describing catastrophe. We have anomalous sites that predate the accepted timeline. We have ghost populations who contributed substantially to modern human DNA and left no other trace. And we have a 98% unexcavated planet, a quarter of whose former territory is currently underwater. None of this individually proves a lost civilization, but all of it together creates the most coherent framework I've found for why we might not know something that we should. You know what I keep thinking about? Those ghost populations. The idea that 30 to 40% of someone's ancestry comes from people we have literally no record of, no culture, no name, no scratches on a cave wall. They lived. They survived whatever happened. They passed on their genes to children who survived to adulthood and had their own children. Their biological legacy persists in millions of living people today. And we know them only as a mathematical residue in a genome dataset. That's not a mystery I find comfortable. It's one I find necessary to sit with. Before we go further into the evidence, I want to slow down and do something that I think makes this entire conversation more honest. I want to question what we're actually looking for. Because there's a conceptual trap at the center of the lost civilization debate. When most people, including most researchers on both sides, imagine a pre-ice age civilization, they imagine something that looks like us. Cities. Writing. Metal. Roads. The physical infrastructure of a settled, surplus-generating, technology-producing society. And then they note, correctly, that none of that has been found. End of conversation, some people conclude. But technology is not a single path. It's not an inevitable escalator from stone to steel to silicon that every sufficiently intelligent species must ride in the same sequence. The path our civilization took, toward permanent physical infrastructure, written record-keeping, large-scale metallurgy, is one path. It's the path that happens to generate the most durable archaeological evidence. That may be creating a massive sampling bias in our understanding of the past. Consider the Amazon. Across the Amazon basin, researchers have identified extensive deposits of terra preta, dark earth, that turns out to be human-engineered soil, deliberately enriched with charcoal, bone, and organic waste to dramatically increase agricultural productivity. It's invisible from the surface. It has no superstructure. It looks, to a casual observer, like unusually fertile dirt. Yet it represents a sophisticated, long-term, large-scale agricultural technology that transformed the ecology of one of the world's largest biomes. Before researchers developed the analytical tools to recognize it, it was just soil. The civilization that created it was written in chemistry, not stone. The astronomical knowledge encoded in early Holocene structures raises a related question. The solar alignments at Newgrange in Ireland are precise to within minutes of arc for the winter solstice sunrise, accurate enough that the chamber fills with light for approximately 17 minutes on the solstice morning, and only then. The astronomical alignments at Göbekli Tepe reference star positions that correspond to the sky as it appeared between 10,000 and 12,000 years ago. Precise astronomical observation of this quality requires not one clever person but generations of systematic observation, comparison, and record-keeping. Where did that tradition begin? How long had it been running before it was encoded in these structures? Several mainstream archaeologists, not fringe voices, have argued that maritime civilizations are systematically underrepresented in the archaeological record. Coastal peoples who built in wood and reed, navigated by stars, traded over ocean routes, and lived on shorelines that are now 30 to 100 meters below sea level would leave almost nothing detectable. Not because they were less sophisticated, but because their material culture was adapted to environments that no longer exist in accessible form. The Hopewell culture of North America, active roughly between 100 BCE and 500 CE, maintained a continental trade network spanning 2,000 miles, connecting communities from the Gulf of Mexico to the Great Lakes, moving copper, obsidian, mica, and carved objects along routes that crossed multiple river systems. They did this with no writing, no large-scale metal production, no permanent urban centers. The sophistication of their social and economic organization is only apparent when you map the distribution of artifact types across the continent. Nothing about an isolated Hopewell site, viewed alone, announces complex trading civilization. The complexity is relational, not structural. I'll be honest about where my thinking lands on this. I don't think we're looking for Atlantis, not golden spires and advanced energy technology in the way science fiction imagines it. I think we might be looking for something both more modest and more profound, a human community that spent tens of thousands of years developing deep, transmissible knowledge about the sky, the soil, the ocean, and the patterns of the living world. A civilization whose primary record was not carved in stone but carried in mind, in practice, in the bodies of people who survived a catastrophe and passed on what they remembered. The fact that we can't find them in our excavations might say as much about what we've decided counts as evidence as it does about whether they existed. In 2023, a peer-reviewed paper in a mainstream geology journal did something that caught the attention of researchers across several disciplines. It formally proposed that the Younger Dryas impact hypothesis be elevated from controversial hypothesis to a working model warranting coordinated research programs. That might sound like academic bureaucracy. It is not. In the culture of peer-reviewed science, that language carries significant weight. It means the evidence has crossed a threshold. From the original Firestone paper in 2007 to the current literature, the number of supporting peer-reviewed publications has grown from 1 to more than 50. The sites confirming the black matte boundary and the associated nanodiamond and platinum anomalies have been verified on every inhabited continent. Papers supporting the hypothesis have appeared in Nature, Science, and the Journal of Geology, the highest-tier publications in their respective fields. The Younger Dryas impact hypothesis is no longer journal of last resort territory. The Gunung Padang paper, despite the fierce methodological criticism it received, passed peer review at Archaeological Prospection. The reviewers did not dismiss it. They critiqued specific methodological choices and called for independent verification. That is the correct scientific response to a challenging finding. It is engagement, not rejection. And engagement keeps the question alive in formal scientific discourse. At the institutional level, UNESCO and the National Geographic Society have both committed funding to systematic underwater archaeology programs targeting continental shelves, explicitly motivated by the desire to recover evidence of Ice Age habitation. This is significant because institutional funding follows credibility. Organizations like these don't fund hypotheses they consider pseudoscience. The broader human origins picture has also been repeatedly revised upward in complexity in the last several years. Homo sapiens arrived in the Philippines approximately 67,000 years ago, dramatically earlier than previous models predicted. They reached Australia at least 65,000 years ago, requiring open ocean navigation across the Wallace Line, a significant maritime capability at an early date. The earliest credible evidence for human presence in the Americas is now being pushed back toward 30,000 years or beyond by sites in Mexico and Brazil, though this remains actively debated. Each of these earlier-than-expected arrivals expands the temporal window for complex pre-Ice Age activity and widens the geographic scope of what we don't know. The language in academic publications about Göbekli Tepe has measurably shifted since the 1990s. The word astonishing has appeared in peer-reviewed papers. The discovery of 60,000 hidden Maya structures recalibrated the entire field's prior probability estimate for hidden complexity. It is now empirically established that major civilizational infrastructure can be completely invisible to conventional archaeology. That fact has consequences for how we evaluate absence of evidence everywhere. What has not changed? No mainstream archaeologist has endorsed advanced lost civilization as a working model. The gap between more complex than previously understood and civilization capable of organized technology at scale remains substantial. I want to be clear about that because intellectual honesty requires it. The shift is in the direction of openness, not conclusion. There's a particular kind of satisfaction in watching an idea that was laughed out of academic conferences in 1995 slowly, painfully make its way into legitimate discussion, not because it wins in some triumphant dramatic reversal, but because the conversation becomes more honest, more complete. That is what I see happening in this field right now. It is slow. It is grudging. But it is happening. Now I want to try something that feels slightly dangerous. I want to tell you what I actually think. Not what the evidence proves. Not what mainstream science currently endorses. What I, sitting with all of this research for months, actually believe, and why I think the question itself may be the most important thing in this entire conversation. Here is my honest assessment, held with appropriate uncertainty. I think it is more likely than not that organized human communities, complex enough to develop and transmit the astronomical and ecological knowledge encoded in early Holocene sites, existed before the Younger Dryas event. I think those communities were primarily coastal. I think they lived on land that is now between 30 and 130 meters beneath the ocean's surface. I think the combination of the impact event and the subsequent sea level rise erased the physical record of their existence with a thoroughness that we have not adequately accounted for in our standard absence of evidence arguments. I hold this with approximately 60% confidence. And that number matters, because 60% is not certainty. It is a working hypothesis, held loosely, subject to revision. If the next decade of submarine surveys finds nothing, my confidence goes down. If they find the equivalent of Doggerland's 60,000 structures, it goes dramatically up. What the evidence does not support, in my reading, a technologically advanced civilization in anything resembling the science fiction sense. No evidence for large-scale metallurgy, no evidence for synthetic energy sources, no evidence for written transmission of technical knowledge at scale. The evidence is better fit by sophisticated oral cultures with advanced astronomical, agricultural, and ecological knowledge, cultures that were extraordinarily capable by human standards, and that would still represent a profound revision to our self-understanding if we found them. That is still a civilization worth finding. That is still a history worth recovering. The deeper reason this question refuses to go away, the reason it has gripped human imagination from Plato's dialogues to present-day genomics papers, is that it is never really about the past. It's about us. If a civilization can rise, become sophisticated enough to encode astronomical precision into architectural stone, and then vanish so completely that 12,000 years later we can't agree on whether it existed, what does that mean for the civilization we're building right now? Our cities sit on the same coastlines. Our knowledge is increasingly stored in cloud infrastructure rather than in trained human memory. The question of what survives is not only historical. It is present tense, and it is urgent. At the start of this documentary, I asked you, what if the textbooks have a 12,000-year blind spot? I don't think I can prove they do. But I think the honest answer, the genuinely, carefully honest answer, is that we don't yet know that they don't. And that distinction, between no evidence and not yet found, is the most important sentence in this entire documentary. I'll tell you what actually got to me in 6 months of making this. It wasn't the dramatic impact evidence. It wasn't the paradigm shifts in academic journals. It was the ghost populations in the DNA data. These were real people. Their genetic material is literally present inside millions of people alive today. They had children who survived catastrophe. They passed something of themselves forward through time in the most intimate way possible. And we don't know their names. We don't know what they called the river they lived beside, or what they said to their children at night, or what they believed happened to the dead. That's not a scientific puzzle to me. That's a grief. And I think science is allowed to hold grief. I think we are allowed to feel the weight of what was lost, even when, especially when, we cannot prove exactly what it was. This conversation is just beginning. The next decade of underwater archaeology, genetic analysis, and deep-sea sonar mapping will either validate or definitively close several chapters of this story. I will be watching every paper, every survey, every press release from every continental shelf program with the same obsessive attention I brought to building this documentary. And I hope, wherever you are when those findings start arriving, you'll be thinking about what we talked about today. In this documentary, we stepped into Earth's deepest blind spot, the 12,000-year window before the reset, when the coastlines held a world we may never fully recover. We looked at the geological evidence of catastrophe written in nanodiamonds and charcoal, the genetic signatures of disappeared peoples embedded in living human DNA, the anomalous sites that predate our accepted timelines, and the scientific tools now slowly closing the distance between what we know and what we've lost. The truth behind our origins may still be out there, 120 meters below the ocean's surface, in a topographic dataset waiting for the right sonar array, the right research team, the right question. What we've established today isn't a lost civilization. It's something more valuable, a legitimate reason to keep looking. If this documentary shifted something for you, the timeline, the evidence, the question of what civilization even means, I'd genuinely want to know which part landed hardest. Not because the algorithm wants engagement, though it does, and I'm not pretending otherwise, but because the comments on videos like this one are where I actually learn things. Someone in the comments of my last video sent me a paper that changed an entire section of this documentary. So, what did I miss? What question do you want me to follow next? What did I get wrong? Tell me below, and I'll read it. And if you want to be here when the underwater surveys start publishing results, and I believe they will, within our lifetime, reshape this entire conversation, then subscribe to this channel. We have a lot more of Earth's hidden chapters to open together, and the next one might be the most interesting yet. The next documentary takes us somewhere that may hold the most intact evidence of pre-ice age human activity anywhere on the planet, and it is not where anyone expected to look. I've been sitting on this research for 3 months, waiting until this video was done. I think you're going to find it worth the wait. Here is what we haven't talked about yet, and it might be the part that changes everything. For the past 30 minutes of this documentary, we've been looking at absence. At what's gone. At the mechanisms of erasure, at the ghost populations in the genome, at the underwater shelves where an entire chapter of human life dissolved into sediment and saltwater. That's a difficult space to sit in for a long time, and I want to acknowledge that before we move forward, because what comes next is actually different in character. What comes next is about finding. In 2010, archaeologists working in the jungles of Cambodia used a technology that had only recently become affordable and airborne to look at the areas surrounding Angkor Wat, a temple complex that had been studied for over a century. What they found stunned the field. Hidden beneath the jungle canopy, invisible to every previous survey method, was an entire urban grid. Streets, reservoirs, residential neighborhoods, infrastructure, a city of well over 100,000 people that had simply not been detectable from the ground. It wasn't buried. It wasn't destroyed. It was just covered by leaves and time. The technology that found it was LiDAR, light detection and ranging, and it works by firing millions of laser pulses from an aircraft, measuring how long each one takes to return, and building a three-dimensional topographic map of the surface below, stripping away vegetation mathematically to reveal what the ground actually looks like underneath. The Angkor discovery was not a minor refinement to existing knowledge. It fundamentally rewrote the population estimates, the geographic extent, and the economic complexity of the Khmer Empire. In a single survey campaign, after more than 100 years of conventional archaeology at the same location, that is the scale of revision LiDAR is capable of producing, not incremental updates, but categorical rewrites, and archaeologists are still processing the implications. Now here is the thing that matters for this documentary. LiDAR works on land. It strips jungle. It reveals what ground-based surveys miss. And what that means is that every region of the world that was previously forested, that was inhabited during the period we're discussing, 12 to 15,000 years ago, when global sea levels were dramatically lower and the continental shelves were exposed land, and that has since been studied only through on-foot archaeology and aerial photography, is now a candidate for radical revision. Not hypothetically, not speculatively, actively, with surveys already underway. In the Yucatan Peninsula, LiDAR surveys between 2017 and 2022 revealed Maya infrastructure connecting sites across distances and at densities that previous surveys had entirely missed. In the Amazon basin, LiDAR imaging over the past decade has revealed what researchers now call garden cities, large, planned settlements connected by raised causeways, covering areas comparable to modern metropolitan regions, in a rainforest that conventional wisdom had long held was too inhospitable for complex civilization to develop. In the highlands of Sri Lanka, a 2021 survey revealed an interconnected network of ancient monastic sites, irrigation systems, and settlements invisible from the ground, pushing back the established dates for organized urban life in the region by centuries. In each of these cases, the revision was not incremental. It was categorical. But here's what actually matters for our question, and this is the part I've been building toward for the past several minutes. LiDAR, in its current form, does not work underwater. The laser pulses do not penetrate water at depths that matter for our purposes. This seems like a limitation, and it is, but the field has not stopped moving. Green wavelength LiDAR, which uses a different frequency of light, can penetrate shallow coastal water, up to approximately 30 meters in clear conditions. That covers some of the most critical nearshore shelf areas. For deeper surveys, the equivalent technology is multi-beam sonar, an acoustic mapping system that fires sound pulses across a wide swath of the ocean floor and returns centimeter-resolution topographic maps of submarine terrain. And multi-beam sonar surveys of continental shelves, the areas that were dry land during the last glacial maximum, the areas where coastal populations would have lived, the areas now sitting between 30 and 130 meters underwater, are actively expanding. The challenge is not the technology. The challenge is coverage and funding. Surveying a continental shelf at the resolution needed to detect architectural features, stone foundations, earthworks, cleared areas, anything that would distinguish deliberate human modification from natural topography, requires resources that archaeology, as a field, has historically not had access to. That is beginning to change. The offshore energy industry has been conducting high-resolution sonar surveys of continental shelves for decades, for purposes entirely unrelated to archaeology, pipeline routing, drilling site assessment, cable laying. These surveys cover enormous areas at resolution far higher than anything archaeology has funded independently. And researchers are beginning to formally request access to those datasets. In the North Sea, the Doggerland surveys I mentioned earlier used exactly this kind of industry sonar data, repurposed for archaeological investigation. The results: 60,000 Mesolithic structures, mammoth bones, worked flint, came not from a new archaeological expedition but from the reanalysis of data that had been sitting in energy company archives for years. This is the part where I genuinely have to pause and say, we are almost certainly sitting on evidence that has already been collected. Not speculative evidence. Not future evidence. Survey data that exists right now, in databases owned by energy companies and national geological surveys, that has not been reviewed by archaeologists looking for pre-Ice Age occupation signatures. The question of what happened on those exposed coastal shelves 12 to 15,000 years ago may be answerable, at least partially, at least probabilistically, using data that is already in existence. The institutional and bureaucratic barriers to accessing that data are real, but they are not scientific barriers. They are logistical ones. And the history of science is largely the history of removing logistical barriers to questions whose answers were always there. There is a project underway, the Submerged Landscapes Atlas of the North Sea, that is doing exactly this, systematically building an archaeological map of Doggerland using repurposed industry survey data. Early results are not just confirming the scale of Mesolithic occupation. They are revealing landscape features, river valleys, lake basins, coastal headlands, that would have made Doggerland one of the most ecologically productive environments in Europe during the period of its occupation. Not a marginal environment. Not a survivalist landscape. A rich, resource-abundant territory that would have supported dense, stable, long-duration human settlement. The kind of environment that produces cultural complexity, not just subsistence. Extend that logic globally. The Persian Gulf was almost entirely dry land during the last glacial maximum, forming a shallow basin, sometimes called the Gulf Oasis hypothesis, with a river system running through it fed by the Tigris, Euphrates, Karun, and Wadi Batin rivers. This basin would have been one of the most resource-rich environments on the planet during the height of the Ice Age: fresh water, fertile floodplain, access to marine resources at the basin's southeastern edge. Its inundation, as sea levels rose after the Younger Dryas, would have pushed populations northward into Mesopotamia in historically documented directions. The genetic and cultural signal of a highly sophisticated Gulf Basin population that was displaced, then compressed, then forced to rapidly rebuild social organization in a new environment, that signal looks remarkably like what we see in the archaeological record of early Mesopotamian civilization. I am not asserting that the Gulf Oasis was the cradle of everything. I'm saying the overlap between where sophisticated coastal populations would have been concentrated and where early historical civilizations emerged is not accidental, and submarine archaeology of the Gulf floor could test this hypothesis with direct physical evidence. The same logic applies to the Sunda Shelf, the enormous area of shallow sea floor between Sumatra, Java, Borneo, and the Southeast Asian mainland that was exposed land during the last glacial maximum. This was not a narrow coastal strip. It was a landmass larger than India, with river systems, forests, and every ecological feature needed to support large, complex human populations. The genetic evidence for an extraordinarily diverse and ancient population in this region, populations that contributed genetic lineages now found across islands Southeast Asia, the Pacific, and Australia, is substantial and growing. The Sunda Shelf archaeology is almost entirely unexamined. The water is relatively shallow, the sonar coverage is expanding, and the evidence for occupation is precisely where you'd expect it to be. The work simply hasn't been done yet at the scale the question deserves. This is the shift happening in real time. Not a shift from skepticism to belief, that framing is wrong, and I want to be careful about it. The shift is from absence of data to presence of testable hypotheses supported by multiple independent lines of evidence. That is a different thing. Hypotheses about pre-Ice Age coastal civilization are no longer in the category of untestable speculation. They are in the category of adequately motivated research directions, and the tools to pursue them exist. That's new. That's meaningfully, historically new. And it means the next decade of underwater surveys, conducted with the right instruments and the right questions, will produce answers that were simply not accessible to the previous generation of researchers. Think about what it means to define civilization. We tend to define it by what survives: stone, metal, fired ceramic. We define it by what our particular taphonomic environment, our particular preservation window, has allowed to reach us. That definition is not wrong, exactly, but it is circular in a way that rarely gets acknowledged. We define civilization as what lasts. Then we look at what lasted. Then we conclude that civilizations that didn't last either didn't exist or weren't really civilizations. The logic feeds itself. What if we tried a different definition? What if civilization is the transmission of knowledge, across generations, at a scale and fidelity sufficient to allow cumulative improvement? Not the stuff it gets written on. Not the buildings it inhabits. The act of passing understanding forward, such that each generation begins with what the last generation learned, rather than starting from scratch. By that definition, the oral cultures of pre-agricultural humanity were not pre-civilizational. They were civilized. They had to be. The astronomical knowledge encoded in Göbekli Tepe's pillar arrangements did not appear from nowhere in 9600 BCE. Someone taught it. Someone learned it. Probably for thousands of years before the first stone was carved at that site. The knowledge was old before the monument was new. The trouble is that oral transmission leaves almost no physical trace. A story survives through being told, not through being buried. And when the people who tell it die without descendants, or when catastrophe disrupts the chain of transmission across a critical number of generations, the story simply stops existing. This is not a metaphor. This is the mechanism. Linguistic surveys of language extinction in the modern era document the process precisely. When a language community falls below a threshold size, the pressure to shift to a dominant language becomes overwhelming, and within 2 to 3 generations the language is functionally gone, along with every piece of knowledge, every nuance of ecological understanding, every cosmological framework that lived only in that language. We are watching this happen right now, in our lifetimes, to hundreds of languages. Multiply that process by a catastrophic event that kills perhaps 30 to 40% of the population in affected coastal zones, compresses survivors into smaller groups, and forces migration into territories already occupied by other populations, and you have a formula for the complete, irreversible loss of whatever those coastal communities knew. That is the mirror problem. What we are describing, the mechanisms of cultural extinction, the fragility of oral transmission, the way catastrophe doesn't just kill people but kills knowledge, this is not only a historical phenomenon. We are looking at the past and seeing the present. The knowledge systems most at risk in a catastrophic scenario today are not the ones written on servers, because servers require maintained infrastructure. The knowledge systems most at risk are the ones held by small communities, transmitted through practice rather than text, embedded in relationships with specific landscapes and specific ecologies. Traditional ecological knowledge. Indigenous navigational systems. Agricultural practices adapted over millennia to specific microclimates. In a scenario of rapid civilizational disruption, and there are several such scenarios that are not in the category of science fiction, this is precisely the knowledge that goes first. And once it goes, the loss is as complete and as irreversible as anything that happened 12,000 years ago on the Sunda Shelf. This is why the question of what came before the Ice Age is not, ultimately, an antiquarian question. The civilization that may have existed before the Younger Dryas and left no trace we have found yet, that possibility is a mirror. It shows us our own fragility with a clarity that no other historical case quite achieves, because the scale of erasure is so total that it makes the point without ambiguity. A world can go. knowledge can go. People who were real, who were sophisticated, who looked at the stars and understood something about their place in the cosmos, they can become, within 10 or 15,000 years, a ghost in a genome and a question we can't yet answer. That's the scale of what's possible. And sitting with that fact, without rushing past it toward the next dramatic detail, is perhaps the most important thing this documentary can offer. If we are the first civilization, if the standard timeline is exactly right and there's nothing beneath us but foragers and nomads stretching back into undifferentiated prehistory, then we are an unprecedented experiment in complexity, and we have no model for what happens to experiments like us on geological timescales. If there was something before us, something sophisticated enough to build in astronomical alignments and encode knowledge in monument architecture, something that rose and was erased so thoroughly that we're still arguing about whether it existed, then we are not unprecedented. We are a recurrence. And a recurrence carries with it the sobering weight of precedent. Whatever came before us, the planet did not break. Life continued. The experiment was attempted again. But the previous attempt did not get a warning. We might be the first version of this story that can see its own ending far enough in advance to write a different one. That possibility, burned not through mysticism but through the hard work of genomics, geology, archaeology, and sonar survey, is worth every minute of this documentary. And it's worth whatever comes next, in whatever underwater shelf or ancient genome dataset or newly translated astronomical alignment holds the next chapter of this story, waiting to be read by someone who knows what questions to ask. The ocean floor is not empty. The data archives of the offshore energy industry are not exhausted. The genomes of living humans are not fully interpreted. And somewhere in that intersection of unasked questions and uncollected evidence is an answer that will either close this chapter of human history or open it wider than anyone currently imagines. We just launched ourselves into the search, and honestly, if a 12,000-year-old ghost population buried in your own DNA doesn't make you want to subscribe and watch where this goes next, I'm not sure what else I can do for you.